We are officially recording right now. Okay, you are officially being recorded right now. What I wanted to go over is, since your notes are due tomorrow night at midnight, some of you guys are still not quite getting your verification pages the right way. All right, now the verification pages are incredibly important because that's the only way I can verify that you're watching your teaching videos. Yes, I can see that your notes are filled in, but the verification page is the only way I can be sure that you watch the teaching videos. And the teaching videos are important because we have so little time in class. Okay, we have so little time in class, and we want to make sure that you get covered all of the information. And not only that, with the teaching videos, you can stop and rewind them if something is confusing, or you can go fast over something you already know. When it comes time for a test, you can restudy them. So these teaching videos are incredibly important, and the only way I'll know if you watched them is when you sign off on the verification page if you're being truthful, and I'm going to assume you are. All right, so the way the verification pages work is that it's the last page of your notes, and if you have to have a real signature. Typed signatures will not work. It has to be a real signature. Some of you guys can write with your mouse, or you can like put it on your phone and sign with your finger. Okay, either one of those works just fine. Some of us, though, most of us have to put it onto notebook paper. And when you do it on notebook paper, you've got to do it like I'm going to tell you right now. The first thing is you've got to have the title of the chapter or the section number. Like right here, you would call it 3-2 notes. It has to have the title on the top written in ink, because I have some people who are trying to recycle these, and that's not going to work. All right, so you have to have the section number on top in ink. Then you write the 3 things you're agreeing to. The 3 things you agreed, you have to list them. The 3 things you're agreeing to is, yes, you're agreeing that your notes are completely filled in. Yes, you're agreeing that you watched the teaching video. And yes, you read through the notes while you watched the teaching video. That's the 3 things you're agreeing to. The 3 things your parents are agreeing to is they saw that all your notes are filled in. They know for a fact that you watched the teaching video, and they asked you afterwards, do you have any questions? And either your parent tried to help you figure out the questions, or you guys together got hold of me to ask me any questions. All right, so what you do then is you're going to list the title number on top, list the 3 things you're agreeing to, the 3 things your parents are agreeing to, and then you sign it. Once you've done that, you take a picture with your phone and submit the picture to Schoology. All right, that's the only way you're going to get your credit for your verification pages. Most of you are doing just fine. We've been doing this since the very beginning. Most of y'all are doing just fine. Some of you are still having some trouble, so I went over it again today. All right, does anybody else have any questions strictly about verification pages right now? All right, this chapter is about the atmosphere. Okay, this section is about the atmosphere. And I want to go over some of the details about the atmosphere. Now, just about everything I'm saying now is also in the teaching video, but I'm also going to try to record this video for you today, and you'll have it also. So in the atmosphere, we know we started off this chapter with the Earth spheres, right? You have 4 spheres of the Earth: the geosphere, the atmosphere, the hydrosphere, and the biosphere. Okay, geosphere, that's the plate tectonics, the crust, earth, crust, core, and mantle. That's the stuff we covered in section 1. Today we're doing the atmosphere. Okay, the next section puts hydrosphere and biosphere together. Okay, this section we're on is the atmosphere. The 4 spheres of the Earth interact together. They're the Earth life support system. So today we're focusing on the atmosphere. All right, now in the atmosphere, those are the gases in the air. Since we breathe oxygen, do you see my pie chart here? Since we breathe oxygen, almost everybody thinks, since oxygen is so important, a lot of people think that oxygen is the biggest part of the atmosphere, but it's not. Oxygen is only about 21%. Okay, this red part here, that's the oxygen. It's only 21%. This whole big blue section, that's nitrogen. We don't even use nitrogen. All right, we don't even use it, but at least nitrogen doesn't hold heat, and neither does oxygen. And when we're talking about Bailey, you have your hand up? Do you have a question, Bailey? Nope. Okay. All right. So oxygen and nitrogen don't hold heat. And when we get into the greenhouse effect, which our next discussion day next week is going to cover greenhouse effect and the heat transfer in the atmosphere. So that'll be our next discussion day. But when we get to it, nitrogen and oxygen don't hold heat. The only three big guns that hold heat. Now, when we talk about heat, you know, you've heard of global warming and the greenhouse effect, okay, and the planet getting too hot and melting all the glaciers. Okay, that's global warming. There are three gases in the atmosphere that are the biggest ones that do that. The three big guns are carbon dioxide, methane, and water vapor. Those are the three big guns that they hold heat and they cause global warming. Carbon dioxide, which we breathe out, methane, which comes from grasses decomposing, and water vapor, which we also breathe out. Ashley, you have a question? Is it about this right here? Okay. All right. So now that's the composition of the atmosphere. The carbon dioxide, the three big guns, okay? Look at this tiny little bit of pink right here. Do you see how tiny that is? That's the carbon dioxide in the atmosphere. See how tiny that is? Every time we hear about global warming and greenhouse effect and the fossil fuels are putting too much carbon dioxide in the atmosphere, the amount of carbon dioxide we have is tiny, which means it is crazy powerful. Carbon dioxide is crazy powerful. It doesn't take much of it at all to start the earth heating up. You see how tiny the carbon dioxide is, okay? And it doesn't take very much carbon dioxide at all to cause a great big giant effect of greenhouse gases. And in the yellow, we have one of the things in the yellow is this methane. That's the second of the big hitters. Methane is even stronger. It does greenhouse effect even stronger than carbon dioxide does. Yes, Isaiah.
So what if it replaces the biggest part of the atmosphere? Oh, so would that mean the Earth will blow up or like get the?
It would burn up and melt. All of the oceans would evaporate and the atmosphere would be so thick that nothing could live here. It's not that the earth would blow up. It
I
would
mean,
just
like not like
heat
blow up.
up,
I mean, like, yes, yes,
heat
yes.
up crazy. Even if we put carbon dioxide, even as big as just the yellow by itself, see, it's pink right now. If we put even as much as the yellow, the earth is pretty well gone. That's some of the worst stuff that they're predicting right now that could happen when they do like apocalyptic futures, based on carbon dioxide. If it even gets as big as the yellow, we're talking apocalypse. So yeah, it doesn't take much energy. It doesn't take much at all for those things to get crazy bad. So the three big hitters is what I need you to know. Who are the three big main ones? You have carbon dioxide, methane, and water vapor. Doesn't sound like water vapor would be a big deal, but it is. Okay. Carbon dioxide, methane, and water vapor. Those are the three main gases that cause global warming. All right. And again, we're going to cover some more about global warming on the next time we have one of these discussion days. All right. Now talk about the layers of the atmosphere. Okay. It does have these 5 layers. Okay. And one of the ways you'll need to remember them in order, but you can make up a funny little sentence using the beginning letter of each one. Like, like I said, the students make teachers emotional. I've been grading a lot of papers. I've been pretty emotional. All right, so that's one way you could think about it. You just have to figure out which separate the T's, or you can make up your own sentence. Whatever you need to do to get them in order. Okay, you'll need to know them in order. Okay, you'll need to know all 5 of the layers of the atmosphere in order. So make yourself up a funny little sentence. Okay, that'll help you remember them. But let's describe what's happening in each one. Okay, this bottom layer is called the troposphere. This is where all living things are. Nothing alive can exist higher up. Nothing that we know of that exists on Earth. I mean, I'm not talking aliens, but nothing that we know of that exists on Earth can exist in any one of these other spheres, only down here in the troposphere. All right, now we also learned gravity that is part of the geosphere. Okay, the Earth's gravity holds the atmosphere in place for us. That's what holds the atmosphere here. That's why the little things like the moons they don't have an atmosphere because they're too small to have gravity and the atmosphere floats away. So the Earth's geosphere is where our gravity is. Remember, I told you all the spheres interact. The geosphere is what holds on to the atmosphere for us. And because gravity pulls the air downward, down here near the bottoms, we call this sea level. Okay, down here at the bottom, there is a lot more air molecules because gravity pulls them downward. And you know, when you climb a mountain, there's less and less air. It's colder because it's colder, and there's less and less air molecules up here because gravity has pulled them all downward. That's why people like climbing the Himalayas. The people who climb the great big tall mountains actually have to carry oxygen with them because there is so little air molecules up here because gravity pulls them all downward. All right, so anything that can exist lives down here. This is also where all of the weather is. Okay, all of the weather happens down here in the troposphere. The next layer up is the stratosphere. Now, the stratosphere has something incredibly important within it. Okay, the stratosphere, are there living things in the stratosphere? No, all living things happen down here in the troposphere. Even the biggest of the birds, the smallest of the amoebas and water bears and whatever it is can float around the world. No, nothing lives in the stratosphere. But in the stratosphere is something incredibly, incredibly important to us. It's the ozone layer. Let me show you this picture here of the ozone layer. It is part of the stratosphere. Down here's the troposphere. Okay, that's where we live, where all the weather happens, where any living thing is. The next layer up is the stratosphere. And in the stratosphere, it has a special part called the ozone layer. Now, it's not a layer all by itself. It's part of the stratosphere. The ozone protects us from the ultraviolet rays. Now, UVA is just sunlight. It can come through here easily. UVB, that's the stuff that will burn you. UVB burns. UVB burns. I'm talking people like me that really, really light skin. We can spend like half an hour, 45 minutes out in the sunshine, and we are burnt to a crisp in half an hour. Okay, people with light skin like me, we know how bad sunburns are. But the ozone protects us. 95% of the UVB doesn't even come down here because the ozone acts like a shield for us. It acts like a global sunscreen. All right, so if only 5% of this UVB comes down here and it can burn me so quickly, can you imagine what would happen if the full 100% came down? No matter what color your skin was, you'd be burnt in an instant. I'm talking burnt with bubbles and possibly blackening of your skin. All right, that it would be horrible if this ozone did not protect us. And if you've ever seen at like dentist offices and sometimes at the nail shops, the metal instruments that they use, sometimes they'll put them into an ultraviolet light to sterilize the medical instruments. You guys kind of know what I'm talking about? They'll put medical instruments into an ultraviolet light to sterilize them. And by sterilizing, that means they kill all the microbes on this medical equipment so it won't make anybody sick. If UVB can kill the microbes on these medical instruments, can you imagine what it would do to us? Right? That's why the ozone is so important. The ozone protects us from these UVB rays that will burn us. Only 5% comes down here, 95 stays up. And this UVC is so scary even to think about. It's some seriously dangerous stuff right here, this UVC. All right, so what happens though is most of you guys know there was a hole in the ozone layer, or there is a hole in the ozone layer. All right, what it was causing it is there were some pollutants that we put out that were called chlorofluorocarbons, CFCs. Chlorofluorocarbons are some pollutants that we put out that wound up tearing holes in the ozone layer. And more sunlight was able to come through. The UVB, the bad stuff, was able to come through. What happened is with the global winds, okay, the ozone hole settled down near Antarctica. Okay, not very many people live in Antarctica, so it was pretty okay. Except that the people in Australia who live near there, they started to get skin cancer and all sorts of sun diseases really, really quickly, to the point where kids in Australia had to wear hats and sunscreen, thick, like 30, 50 strength sunscreen, even if they were, no matter what color their skin was, even if they were outside in only 5, 10 minutes. the cancer rates were so bad. But what we found out, what happened, was that in the 90s, there was a huge volcano that exploded. It's called Mount Pinatubo in the Philippines. It was a massive volcanic eruption. Some of those ashes went so high up that it plugged up some of the hole in the ozone. And what we learned is that if we let it, the earth can heal herself. Not all of the volcanoes will blow up that high. We talked about this when we did volcanoes. Not all of them will go that high, but some of them go high enough that can help plug up this hole in the ozone layer. All right, so let's go back here. So the ozone layer is not a layer all by itself. It is part of the stratosphere. So troposphere is down here at the bottom. This is where we live. This is where all the weather happens. Stratosphere is the next layer up. This is where the ozone layer is. The next layer up beyond that is called the mesosphere. And this is where the meteorites burn up. Now, I'm not talking big dinosaur killing meteorites. I'm talking there are small meteorites that are flying through space all the time. If you look at the moon, all those craters you see on the moon is because of how many meteorite strikes there have been. Remember, the moon doesn't have an atmosphere because it's so small. Any meteorites that are flying around around space, which there are lots, will hit straight on the surface of the moon. Well, for us, our mesosphere burns them up. You know, you have friction, right? So friction between the meteorite and the air molecules that are up there completely burns up the meteorites before they hit us, the smaller ones. They didn't do any good for the dinosaurs. But the small ones, whenever you see a shooting star, it's not really a star. It's one of these meteorites burning up in the mesosphere. That's what the mesosphere does for us. Okay, so we got troposphere, stratosphere where the ozone is, mesosphere where the meteorites burn up. Next layer up is the thermosphere. You know, thermo means heat, right? Like the word for thermometer. It's weird. This is the hottest layer of all of them. This layer is crazy hot. You see this? 12,000 degrees Celsius. Okay, that's crazy, crazy hot. However, you would never feel it. That's where it gets crazy. All right, so what we feel as heat is the air molecules. You know, when you rub your hands like this and you make friction, what we feel as heat is the air molecules rubbing against each other, creating friction. All right. And that's what we feel as heat, is the friction between the air molecules. The thermosphere is 12,000 degrees Celsius. It is crazy hot, but there are so few air molecules up there, they never hit each other, or very rarely hit each other. And the only way you feel heat is when they hit each other and rub. If there's so few of them, they don't heat, they don't hit each other, so you don't feel the heat. It is 12,000 degrees Celsius and is cold because you can't feel the heat because the air molecules don't hit each other. Now that's pretty awesome by itself right there in the thermosphere, but the thermosphere also has something else awesome. Do you see this? There's a layer here within the thermosphere called the ionosphere. Just like the ozone is part of the stratosphere, the ionosphere is part of the thermosphere. If you remember, which you may or may not, when you did physical science, you learned that an atom that has a charge is called an ion. All right, in the ionosphere is a whole bunch of atoms that have a charge. What they do, when the solar rays come shooting off the sun, they hit the ionosphere and make sparks. So the solar rays, and I'm talking this stuff coming off the sun, we know that UVA, B, and C down here coming to us is pretty bad. But this is some serious, awful stuff. This is like X-rays and gamma rays, because that stuff comes off the sun all the time. X-rays and gamma rays like turn the Hulk green. Gamma rays. Okay, they're coming off the sun at all times. And what they do is they hit the ionosphere, these big nasty ones. Okay, the UVA and UVB comes down here and the ozone handles those. But up here at the ionosphere, that's X-rays and gamma rays that are coming off the sun. And when they take those rays, they set off sparks. And when they set off sparks, have you ever heard of the Northern Lights? Like in Alaska and Canada, the Northern Lights? That is the sparks on the ionosphere. when the sun's solar rays hit that ionosphere with the gamma rays and the X-rays and it makes sparks, we see that as the northern lights. And there's also southern lights down at Antarctica too. That's pretty cool, right? So the thermosphere, part of the thermosphere is the ionosphere, and that's where we get the northern lights. The last layer is the exosphere, and that is exiting out into space. This is where we have our satellites. Most of our satellites are up this high. And when we used to have the spaceships that are going now, some of them are going up that high. Now, the exosphere does not have a straight line like this. What the exosphere is where you have less and less air molecules until there aren't any. So it's a very slow, gradual emptiness into space. So you have some air molecules, okay, but there's less and there's less. And so suddenly you look around and there aren't any more, and then you're in space. Okay, so there's not an actual divider line like this. It doesn't go from blue to black. Okay. In the exosphere, it's just there's less and less air molecules until you look around and there aren't any more, then you're in space. Okay. All right, so you're good with the 5 layers. Okay, you're going to need to give yourself a funny little sentence to help you remember them. Okay, and you're good with the composition of the atmosphere, the different things that are in it, and you're good with the
Can
3.
you go off?
What?
Can you go off?
Go up?
Yeah, I was copying this.
Okay, yeah, and I recorded it too. We're recording right now, so you'll be able to see the recording as well. Which part did you want to hear again? Well, we've got the recordings. Does anybody else have any questions? What are the 3 big guns for the global warming? Carbon dioxide, methane, and water vapor. Those are the 3 big guns that cause global warming. All right. Any other questions for me today? Okay, remember that your notes are due tomorrow night at midnight. I don't necessarily have anything to write down for this for you, but you're going to need to memorize these 5. So you probably want, like Ashley's doing, she's writing some notes down. You'll probably want to do that. A lot of this stuff is also covered in the teaching video that you'll find on the same page where your notes are, 11.5. Does anybody have any questions? Okay, I'm going to stop the video. Let's see if I can figure out how to stop the video. All righty, got that. Stop recording.